Okay. Great, thank you. And really quickly, I wanted to introduce our three panelists. We have three great speakers today that are going to be giving kind of a 30,000-foot overview about their specific topics of expertise in climate change. And then really, we really hope that, you know, questions and some of the observations that folks share will help kind of guide the rest of the conversation. So we'll be starting with Rick Thoman. He is an Alaska climate specialist with the Alaska Center for Climate Assessment and Policy, with the University of Alaska Fairbanks, and he'll be giving us kind of that 30,000-foot overview of what does the climate data say about what's happening in the Chugach region. Then Jeremy Littell, who is a research ecologist focusing on climate impacts with the Alaska Climate Adaptation Science Center and the Department of the Interior, will share with us some of the tools and resources for climate projections that are available for our region and exactly how to use those and what those mean. And finally, we'll have Michael Opheim, who is CRRC's Tribal Fish and Wildlife Liaison, talking about climate impacts on fish and wildlife resources and the environment and kind of what we are observing on the ground in our region and what he has seen in his community of Seldovia. So without further ado, I will go ahead and stop sharing and turn it over to Rick.
All right, thanks very much, Erin. And let's see if we can make the technology work one more time. Let's see. Can you see that? Look good? All right. Well, very honored to be here. Thanks for the invitation to talk about my little piece here is going to be kind of what we have seen in the changing climate in the Chugach region. Very happy to be here with you from Trothia campus here at UAF on the traditional and never ceded lands of the Tanana Dene people. So just to start, so we're all talking about the same thing. Sometimes we see a confusion between weather and climate. Sometimes that's intentional, sometimes it's not. But weather is really the instantaneous state of the atmosphere. What's happening right now? What's the wind speed right now? What's the precipitation rate right now? And at its broadest, climate is simply any kind of statistic we can make from all those instantaneous weather. So that could be the average high today, or it could be how often does Cordova get 3 inches of rain in one day? So it's a statistic you can make out of instantaneous weather observations. It's climate, so it's a pretty big basket there. So both weather and climate are, of course, the end result of a multitude of processes operating at time scales from seconds to millennia. And if we take a long enough view, like continents moving around, you know, millions and millions of years. And the importance of those vary depending on the what, the where, the when, the questions of interest. And so this comes into play here when we think about changing climate. You know, so we've got this long-term trend underway. We also have things like, you undoubtedly have heard that we have now a El Nino in progress in the equatorial Pacific. And all of these things are all happening at the same time, and they're interacting. And the end result of these and many, many other factors result in what you see outside your window right now to what you have experienced in your lifetime as far as environmental change. So another related to that weather versus climate, right now we live in the golden age of weather observations. We have a lot of weather observations in the Chugach area. This is just a graphic I pulled up that plots a fair number, not every single one, but a fair number of the weather observations that were available about 10 o'clock on Tuesday. And you can see here You don't need to read that. These are just temperatures and winds plotted, but you can see there are a lot of observations in the area. Some of these we have as a result of the monitoring efforts in the wake of Exxon Valdez. Others are airport stations. Many are other types of weather stations from all kinds of sources, for whether NOAA, whether the FAA, other federal agencies, state of Alaska has a few, and of course, private observations. That's for weather. The Chugach region, though, is really lacking in long-term climate observations, places that take things like observations of things like daily high and low temperature, total precipitation, total snowfall, day after day. And in fact, in the Chugach region, the only place with a reasonably unbroken set of observations at about the same place is really the Cordova Airport. So in that sense, while we've got a lot of weather data, we don't have good long-term climate observations in the Chugach region. But luckily, we have computer models to help us out. And now we're just going to jump into the quick overview of how things are changing. And I wanted to give you this Alaska statewide view to help you put in perspective how things are changing in the Chugach region compared to the rest of Alaska. I just circled kind of the Chugach region, south central Kenai Peninsula there in these graphics for your eye. So you can see in Alaska, people ask me all the time, how is temperature changing in Alaska? Well, obviously, Alaska is a big place. There's no one answer, right? Really dramatic changes on the north slope into northwest Arctic Burrow. A lot of that is related to the dramatic decline in sea ice. But you'll notice on this graphic, there is no blue color on this map. There is no place in or around Alaska that has cooled over the last 50 years. For the Chugach region, if we just looking at the Chugach region, we see that the average annual temperature has increased about 3 degrees Fahrenheit in the last 50 years. Now, I show 50 years here in some of these graphics. There's nothing magical about 50 years. I pick it because it's a nice round number, half a century. And it also corresponds to the better part of an adult working lifetime memory. So I'm probably not the only one on this call that can remember weather before 1973, but I don't have an adult perspective of that. So but there's nothing magic about 50 years, just what I've kind of chosen. Precipitation. Now, this is kind of interesting. This looks somewhat different than the temperature graphic. Again, 50-year change in the average total precipitation, this time in percent. Now, you can see that while there is more of those kind of greenish, bluish, turquoise colors on the map, there are areas that have had a little bit, not much, but a little bit of a trend towards less precipitation. And interestingly enough, it's actually split in the Chugach region with a slight decline, mostly kind of western Prince William Sound, Kenai Peninsula area, but eastern Prince William Sound over to east of Cordova and the Copper River Delta, a slight increase. But these are really small changes overall. For the Chugach region as a whole, the average decrease is only about a 1.5% over the last 50 years. So to put that in perspective, if you average 100 inches of precipitation, that's rain plus melted snow, a 1.5% decrease over the course of a whole year, that would mean you have about 1.5 inches less. Out of 100 inches, that'd be pretty hard to notice. How about snow? Very different story than precipitation. Over a fair chunk of mainland Alaska away from the coast, we don't see much change in the total seasonal snowfall. But near the coast and in general, kind of south of about 60 degrees latitude, we do see a decrease. Across the Chugach region, for all elevations, so I just use the Chugach region, irrespective of elevation, we see a decline of snowfall about 14% in the last 50 years. And of course, it's no surprise why. more of that precipitation in the cold season is coming as rain than snow. If we do also have independent observations at lower elevations, for instance, the Natural Resources Conservation Service snow course been taking obs for about 50 years right out of Valdez, and there we see a 22% decrease in the end of season snowpack, so the amount of water in the snowpack over the course of the 50 years of observations there. So precipitation, not much change. Snowfall down substantially. How about out in the ocean? So my little graphic here shows the temperature in the Gulf of Alaska, and the little insert there shows the area. So a big area. And you can see over that big an area during the warm season, May through October, you can see that temperatures have been warming during the course of the 20th and 21st centuries. And the way I like to do a lot of my plots here, I like to highlight the warmest and coldest values. And you can see that in the 21st century here, for the entire Gulf of Alaska, we see that 7 of the 10 warmest May through October since 1900 have occurred actually since 2004. Really quite a striking increase. Now, the only climate data sets that we have for sea surface temperature that go back a long way are really pretty low resolution. We do have some higher resolution sea surface temperature data sets that only go back to the early 1980s. When we look at those for the near shore areas, for the Chugach region, including Prince William Sound, a little bit offshore of the Kenai Peninsula and eastern Gulf Coast, we see that the average sea surface temperature during May to October has increased about 0.6 of a degree Celsius, or almost exactly 1 degree Fahrenheit over the past 30 years. Now, I just in the interest of time, I won't show it, but I've been showing you annual type statistics here and maps. I do want to point out there's a lot of variability in the seasonality. And so this is a kind of an interesting one. This shows the change in summer precipitation. And you can see that across most of the Chugach region, except maybe down towards Port Graham and Nanwalek, we have really a dramatic increase in the last 50 years in precipitation. Meanwhile, look southwest at Kodiak, and you can see that there's been a substantial decrease. This is strongly suggestive of long-term variations in storm tracks. There's nothing in large-scale climate change that would suggest that the Alaska Peninsula and eastern Aleutians would get drier in the summer and the northern Gulf of Alaska coast would get wetter. We would expect overall to see a wetting trend over most areas at mid and high latitudes. So these kind of seasonal variations are really quite interesting, and they can really be more important than kind of these annual scale changes, at least for the immediate impacts that people experience and effects on lives and livelihoods. So here's the summary slide. It's warming in all seasons, most in winter. Oceans are warming. We've already looked at that precipitation versus snow changes. And of course, I don't touch on it here just in the interest of time. All glaciers in Alaska are receding. And in the Chugach region, of course, that includes both tidewater glaciers and the mountain glaciers. So that's what I've got for you. Thank you very much.
Thank you so much, Rick. We're going to hold questions until after all the panelists. So we will go ahead and move on to Jeremy. If you want to go ahead and share your screen. And thank you so much, Rick, for that great presentation. I know I asked a lot in 10 minutes, and that was very informative.
All right, thanks, Erin. Thanks to all of you for being here this morning. Thanks, Rick, as always, for a great lead out. That's a perfect place for me to start. I'm going to talk about some of the things that Rick mentioned and how they might look in the future. As often is the case, he has a few more details than I've got, but I'll try to highlight some of those that I don't have slides for as we go. So I was asked to talk about climate change in the Chugach region in the future. And if we want to think about changes in climate in the future, we really have to think about the changes that we expect in the things that force climate at a global level. And because climate change is largely driven, as we observe it and experience it, by greenhouse gas changes in the atmosphere, we really have to think about that. And to do future climate estimations or try and figure out what that future might look like, we have to use computer models of climate. And they're driven by greenhouse gas forcing. They have in them the interactions between the ocean and the atmosphere and the land surface and all the different parts of the climate system. We don't have time today to talk much about that. But essentially what you need to know is that we can't precisely predict the future the same way we do weather forecasts on a day or three in the future, in part because there's different pieces of uncertainty that we don't have a complete handle on. For example, those greenhouse gas futures, which are shown in these colored traces on this graphic, after the mid-2000s, they could go up quite a bit depending on global economic policies and our own actions as people using greenhouse gas engines and things like that, right? Or they could be lower depending on commitments globally to decrease the intensity, the carbon intensity of our economies. So we have to build in that uncertainty into future estimates of climate. The more greenhouse gases there are in the atmosphere, the more warming we could expect, kind of like those red lines on the top. Less greenhouse gases to the atmosphere over time, and we could get less warming, as shown in those blue or green lines. There's other sources of variability too, though, that we have to think about in future climate, and climate models don't do as well at some of these. For one thing, there's a number of scientific aspects of the climate system that we still don't perfectly understand, or at least not well enough to predict it at sub-regional scales. And so different models perform differently in different places. For example, Rick talked about sea ice earlier and its effect on the warming trend in Northwest Alaska. To understand a future here, you really have to have models that simulate sea ice well, and some do better at that than others. There are also uncertainties due to natural climate variability. Rick mentioned El Nino and La Nina. Those interannual or even decadal variations, the models don't predict those very well. They simulate them to some degree, but the sequence of them matters for future climate projections. So we have to consider those uncertainties. And then another one is where and when we're working. Some of the places on the planet are much more difficult to model climate than others, in part because of the presence of things like mountains or very strong variability in storm tracks and things like that. Again, not enough time today to go into all of those. Maybe a simpler way to think about this, though, is that we have to consider multiple climate futures when we want to talk about planning for a future and adapting in the places where we live and work. It's very different for us to plan for a high-risk future with lots of warming and end up over-preparing, right? That's expensive, but at least we're ready. It's very different to plan for a low-risk future and end up with high impacts that we didn't anticipate. So somewhere in that range of futures, we have to decide how much risk we're willing to take on as we go forward. One way to think about future climate is to say, okay, let's think of these high-end simulations and these lower-end simulations and plan for both, in the sense of asking, are we ready for these different impacts that we might experience? The best practices for climate information are considered in everything we do here at the Alaska Climate Adaptation Science Center and at UAF. So the tools and information I'm going to show you consider some of that variation. So what do we expect for the future? You may have heard that there's a new generation of climate projections that were run for the most recent Intergovernmental Panel on Climate Change report. We have access to these globally and for the region, but they haven't yet been downscaled for Alaska. And so because these come from climate models that run at relatively coarse resolution, you can see the pixels on the map over here to get an idea of kind of the average resolution the models run at. We'll have those downscaled in the future. The rest of the stuff I'll show you a little bit later in the talk is from the prior generation, but mostly they agree on the futures. If anything, these new models suggest it's likely to even be a little warmer than the prior round. Again, details for another conversation. But the latest generation of climate model projections, if you average the available climate models, and there's 34 of them averaged to make this graphic, for the Chugach region, we're expecting something like 12 degrees of warming by the end of the 21st century, so 2081 to 2100, relative to the historical period 1981 to 2010. And that's a big warming, very large, more than double what we would expect for the planet on average. The winter warming is projected to be quite a bit higher than the summer warming. This is the annual picture that I'm showing you here. And as Rick showed you for the historical trends, there's also a number of different answers to how warm and how fast will it warm in Alaska. And you can see up on the Northwest Arctic coast, the rate of warming is much larger than it is, say, in southern Southeast Alaska or out in the Western Aleutians. For the Chugach region, you can see we're kind of in the middle of those rates of changes that we expect. What about precipitation? This is for annual precipitation again. And for the Chugach region for the 2090s, we expect something on the order of 30% increase in annual average precipitation for a higher warming future, and about 20% if the warming is on that lower end that I showed you earlier. The cool season increase is projected to be slightly higher than warm season. And by cool season, I mean October to March. But really, the seasonality of these changes matters a lot. And as Rick showed you earlier, the differences matter depending on where you look. So if you look at southern Southeast Alaska and the southern West Central Aleutians, I guess we'll put it that way, those have a very similar future projected trend to the summer trend that Rick showed you from the observational data, where they don't increase as much as the rest of the state. And in fact, in some places, actually expected to decrease a little bit. Relative to historical variability might not be that large, but we can't expect that increase. But when it comes to impacts that matter for people and the places that they live and work and the resources they depend on, it's really not just these averages that matter the most. In fact, it's things that are much more difficult to simulate and model. Changes in the water cycle. Rick talked about snowmelt, and we think of runoff timing. When does spring come? When do rivers freeze up, if they do at all? Something called evapotranspiration, which is essentially how much water moves to the atmosphere from the land surface and from plants, right? It's basically the drying ability of the atmosphere, which goes up as temperature increases. Things that people care about also include extremes, right? Droughts, floods, atmospheric rivers, heat waves, these things that we've seen in the news, perhaps more frequently than we used to think of experiencing them, and that change really how we think about risk. These are the kinds of futures that we're really most interested in, rather than just those average changes. And then the idea of global weirding, you might have heard of something like that. Basically, these uncommon events that defy our historical expectation. Rick showed you the 50 years of historical trends, saying that's kind of the realm of the adult lifetime. That forms our expectations. But even people who haven't been around that long are already starting to ask, wait a minute, these things that are happening now, they look different from our previous experience. So things like rain on snow where you don't expect it, or in some cases, higher snowfall than you expect. Other surprises that happen. So we have a lot of scenarios for these. Rick mentioned the trend in snowpack or the lack thereof in some places. As we go into this future, the warming and precipitation changes that we expect, we actually get small increases in wintertime precipitation in larger ones the further north we move, but we get a decrease in the amount of snowfall. So if we want to explore things like that a little bit, there's a couple paradoxes. I told you earlier that the average changes are warmer and wetter over most of the state, but wait a second. More precipitation doesn't necessarily mean wetter for whatever we care about. Maybe it's plants, maybe it's a fire season, maybe it's flows for salmon. The timing, the kind, and the fate of the precipitation that we're talking about really matters, and it changes with temperature. Here's an example I'll give you. We expect cool season precipitation for October to March to increase about 30% in the Chugach region. And this line that I've drawn around our region here in the graphic on the right is one from the Forest Service Chugach vulnerability assessment from several years ago. And I just picked that as kind of an arbitrary way to look at an average for the region. But the snow season could decrease by weeks, and the amount of water in the snowpack by half or more. So if we look at the data for not just precipitation, but how much of it gets entrained in snowpack over the region, we see lots of reds on the map, particularly at the lower elevations, and not very many blues, except at the very highest elevations. What's happening there is as the temperature increases, those highest elevations are still cool enough that the increase in precipitation can come mostly as snow. And so for the cold season, you might get small increases, but they're nowhere near as large in most cases as the increase in precipitation. So this tells you you're getting more rain than snow in many of these places, and the snowpack isn't accumulating at all in some of them where you lose most of the snowpack. So it's wetter, but because it's warmer, there's less snow. Another paradox is that the warm season precipitation could increase as much as 15%, depending on which model you look at. But that evapotranspiration, again, that ability of the atmosphere to pull water out of the land surface and out of plants, that increases faster because the temperature increases are so large. So you can actually get a small increase in precipitation, but soil moisture that's available to trees or plants and runoff that's available for salmon could actually decrease. And the timing of these things could change quite a bit. So we have to be careful about generalities. We have to explore impacts in much more detail based on where we're looking and for what variables concern us most based on the impacts they might have. I don't have time to go into too much more, but I want to show you briefly a tool where you can access the same kinds of data that I've been showing you. It's called Northern Climate Reports. It's a collaboration between our partners at University of Alaska Fairbanks in IARC and the SNAP team, SNAP Tech Tool team, and the Climate Adaptation Science Center. This is what the web page looks like currently. The link should be in the chat there. And it's getting a bunch of updates as we speak, but by the end of the month, it's going to be able to do more than it can right now, so be patient. But what you can do here is go in and type a place or type in a latitude, longitude, or just clunk down a point on a map. Here, I thought, well, let's look at Tititlik. And so you type in something and it gives you options and you click on one. It also has lots of First Nation traditional names for the Yukon and Western Canada, and also Alaska Native place names. And if you find one that's wrong, let us know. We want to know. We want to try to get this right. So anyway, you can click on a particular place, and you can't really see much of the coastline here because many of those sort of video game cells are so dark. But this is the change in that evapotranspiration variable I talked about earlier for a single climate model, the CCSM4 model, for a high emission scenario, RCP 8.5. So you can kind of toggle these and look at different changes or different risks for different assumptions that you might make about futures. And it'll give you the data for that particular area. You can see here, I've just highlighted the spring and summer changes and then the different scenarios that result. So it spits out a table like this. You can download it as CSV or like an Excel type file that you can put in a report if you need to, or you can just look and kind of explore different scenarios. They all kind of say the same thing for this region, though. You get an increase in the amount of evapotranspiration over the most of the region. Sometimes in the high mountains, it doesn't change very much. You can do the same thing for a bunch of different temperature indicators for the same place. Here, it just looks at different thresholds of heat and cold spells and things like that, and just get an idea for the changes. And they're very much like what you might expect. The number of hot days goes up, the number of very cold days goes down, and you get pretty large change in temperature effects in this area. Same thing you can do for precipitation. You can look at the changes in extreme precipitation, which increase pretty substantially as we go forward into that warmer future. Even if the amount of total precipitation doesn't change all that much, more of it seems to come in extreme events, which concerns us, right? So this gets more at the idea of the extremes that actually matter to people. Again, there's a lot of variation. You can explore different models and different emission scenarios for different time periods, but you can get an idea of what we might face in the future. So there are a few more updates coming to this. Eventually, you'll be able to look at a lot of different hydrologic outputs. Again, these are all from climate model futures, right? So the models sometimes need to get outside more. They need more experience in specific places, but they help us get a better idea of the kinds of futures that we may face and move much past that just general average change. And so with that, I'm going to leave you with this slide for a second. You can always find me here, and I can help you access this data for specific purposes if you have impacts assessments that you need to do, or adaptation planning that you want to make more data intensive. And with that, I'll stop sharing.
Thank you, Jeremy. That was a great overview and lots of wonderful tools. And I really like the Northern Climate Reports tools, just for how much you can play around with geography. So if you want to look up, the region is defined by Chugach Alaska Corporation, you can. Or if you just wanted to look up a community level, you can. Or if you wanted to look up like I think that the Chugach National Forest, for example, is one of the subunits you could look up. So it's very cool for that reason as well.
And I should say, right now, the future hydrology stuff I showed you will only work for a point that you put down in the map or a community location. It doesn't yet do it for the bigger geographies that you talked about, like the corporation or the forest boundaries. It will eventually, but first things first.
Awesome. Thank you so much. And again, we're going to save questions until the end, although if you have any questions that you'd like us to address, please feel free to put those into the chat and we'll be sure to come back to those. So without further ado, I will turn it over to Michael Opheim to talk a bit about what's kind of been happening on the ground and observations and impacts on fish and wildlife resources. Go ahead, Michael.
Oh, thank you. I'm gonna leave my video off. I'm having some bandwidth issues here in my carcass, downtown Anchorage. I guess I'll start way back from when I was a youngster in growing up in Soldovia. Noticing how much snow we had, the cold weather we had. We had snow that was in piles, the size of houses, and we'd play in those constantly. Always getting in trouble for playing in those, I guess, too. So just always, somebody was always worried we were going to get plowed under by the snow truck, but we never did. And then the summers were wetter and colder. I remember as a kid, seeing some of the graphs that were just shown, it kind of was jogging memories, that's kind of how it was back then. And the streams would run a bit more, we'd have, with that snow load that we would have, we wouldn't have to worry about streams drying up or drinking water running short. There was things were never thought of until recent years. I remember we had snow on 4th of July one year. I mean, we haven't seen that since it was like 79 or 80 or something like that. It was there in Soldovia. And we don't have the cold in the winter times. In January month, we would have 2 or 3 weeks of minus temperatures. The bays would freeze up. It was cold. People would actually ice skate on the head of the Soldovia Slough, where it's tidally influenced. So it was kind of brackish water, saltwater, freshwater mix, but it would freeze hard enough that you could actually ice skate on it. And it freezes up every once in a while now, but definitely not to the thickness that you could safely ice skate on it. And the snow isn't there. We used to have a lot of snow machines growing up. Those aren't there. It's so it's just the streams, like I mentioned, are almost seasonal now, I guess. Looking at those, you don't have the snow down low that charges a lot of those systems for the salmon. In 2018, 2019, we had a really dry summer, and we actually had a couple streams dry up to the point where the salmon couldn't get upstream, and we had thousands of salmon die off. The fry trying to get out, dried up in pools, and
Oh no, I think we just lost. Oh, he's back.
okay, I'm back.
Okay.
I said my bandwidth was bad, sorry. But yeah, it's so our salmon streams, they dried up there for that summer, and it just seems to be something that we're seeing more. Port Graham, Nanwalek down below us are seeing the same issues with the the low water and low salmon returns. Our moose populations, those have gone away. They're just kind of bouncing back now. Those could have been from over harvest to a point. Our bear populations, those went down, are bouncing back now. But our winters are wetter, are warmer. We have more windstorm damage. You see great big swaths of blown down trees because the ground isn't frozen or it's saturated, wet still, and the winds come through and take out all the trees. It's one I guess the one perk out of that is that you get some firewood when you have to go out and clean up the mess, but that's something that we never experienced when I was growing up. And it's just I it's just been a lot of change over the years. You see the tree line, the shrub line there, the alders and the willows are going farther up the mountains. They weren't up that high when we were kids, and alders weren't near as thick back then either. It just seems like those came in and just took over. A lot of things up high. You used to be able to take a three-wheeler and go up the mountain, and you really can't now because of the alders, the snow. A lot of hills there where you used to be able to slide when we were kids, you can't because of the alders. So it's some of those things are just not there anymore. I think I had some other things in my mind, but they're kind of slipping me right now, so I'll stop there before I start rambling too much.
Well, thanks so much, Michael. I think that firsthand observation is so important because as we heard from Rick and Jeremy, there is so much variability, and it really depends on season and altitude and all kinds of different things, how impacts are actually being coming to light on the ground, essentially. So thank you so much for sharing that. I think at this time I'd like to open it up to any questions, and I'll open it up to folks in the audience first. Does anybody have any questions for any of our presenters?
I had a quick question.
Yeah, go ahead.
So I was really excited to hear about the changes in snowfall and how it's, shifting from being snow to rain. And I was trying to take a whole bunch of notes. But one thing I remembered is that it seems that the overall precipitation is lessening in the region, and the snow is lessening in the region, but the precipitation in the winter is increasing overall, even though more of it's rain, and the precipitation in the summer is increasing overall due to the increase in storms. So is the region just experiencing like very dry springs and very dry falls as opposed to normal? Like, is there areas that you just considered drought, like in the fall or the spring, and then you're having really wet, polarizing seasons? Just a thought on the where precipitation is decreasing when winter and summer are increasing. I guess that would be a Rick question possibly, or I'm not sure.
Sure, I'll be happy to take that. So the precipitation is really almost unchanged in the region. That, like I said, that about 1.5% decrease in the last 50 years, that's really in the noise level. It's really probably best to think about that as not much change, as opposed to overall at all elevations, almost 15% decrease in snow. But to answer your question about the changing seasonality, you're exactly right. We are seeing drier, especially springs in the Chugach region. At the moment, we're not seeing much change in the cold season, or at least midwinter precipitation. As Jeremy showed, that is expected to increase. And we actually do see increases in midwinter precipitation over much of the state. Not all, nobody's drying, but the Chugach region is one of the areas that there's not been much change in the last 50 years. Very different in the spring when there is substantially less precipitation, not just in the Chugach region, actually across almost the entire Gulf of Alaska coast, as well as much of Southwest Alaska and into the interior in the spring. So at that kind of scale, that's not just storm tracks shifting around. But you're exactly right. This change in seasonality, overall, it's in some ways kind of still balancing out. But the difference, the much drier springs now, much wetter summers, that's really where you're starting to get down to the scale that really impacts people's lives, what they do, the ecosystems, freshwater runoff into the oceans, all kinds of things depend on that seasonality. So great question, thanks.
Hi, my name is Caroline. Can you hear me?
Yes, we can.
Okay. I'm sorry, I like to have my camera on usually when I talked, but they changed my monitors yesterday and looks like they don't have a camera now. I'm gonna be off on that. I am with the Chiniga Corporation and I do the grants for the tribe. I do have a question about, I know there's some funding coming up soon for climate change. For that, it would be a good idea to have a climate change adaptation plan. And I don't know if anyone here in the group has any experience with that type of planning for a tribe, or if you have seen one develop.
I would be happy to jump in really quick, but actually I noticed that our panelists are also speaking. So go ahead, Jeremy. I don't want to cut you off.
No. I think you should lead with that. And then if we get to the point of providing support, like either the Tribal Resilience Learning Network or for climate information, then I can tackle that if we need to. But you should go first.
Okay, thank you. Yeah, thanks, Caroline. You know, CRRC has been working with the climate cohort on a regional adaptation plan to try to guide some of how CRRC can regionally support our tribes in understanding and responding to climate change. So we do have some experience. It was an interesting time to do some planning as it kind of started in the middle of COVID. And so I think that might be kind of why it has not been as well known in our region as I would have liked or hoped. But we have been working on that. And I know that that the Model Forest Policy Program that's one of the reasons that they are on board and helping us out as well. And we're helping out with the climate cohort was to help share some of that knowledge of the process of how do you develop an adaptation plan and what do you look at to start building this? And I'll go ahead and turn it over to Jeremy.
So there's a group led by Melinda Chase at University of Alaska Fairbanks, who's one of the tribal climate science liaisons. And they're called the Tribal Resilience Learning Network. And Kristen knows a fair amount about them too. But they have done a lot of work helping various tribal entities develop the required adaptation plans, or at least get the information for it, and to increase capacity for them to develop those adaptation plans. Often those plans want to include specific climate information like I showed earlier, and we can help do that. It's pretty easy to do now that we have Northern Climate Reports tool, at least for the purposes of adaptation plans. On the other hand, it's my firm belief that communities' experiences, or if it's a tribal corporation or a village corporation or whatever, that their experience should lead, right? That kind of other science information that I presented should be in the background, and in some ways agencies want to see that because that's the language they speak, but it's not the main thing. So we can help make that as something to tuck in the back or to help further support those adaptation plans if needed. I think Melinda would be the first person to talk to about that. Maybe Erin knows other resources, but that's how I would start.
Well, thank you so much, both of you. Jeremy, I may send you an email shortly asking you for Melinda's information. And Erin, I don't know if that's going to be, do you have like, when do you think your plan is going to be ready for the region? Or if is it possible for us to take a look at it? Or
yeah, absolutely. I have been developing the draft, and I'm actually going to be showcasing it on the November. It's not quite finished yet, but I was going to showcase the draft on the November webinar to ask for feedback, input. It's going to be finalized by or get approval and finalized by our board in February of 2024. So we're kind of in the final stages of that process, and definitely looking for further input and feedback. And this is kind of, well, this is still up in the air, but CRRC was, and I need to reach out to a bunch of folks on this call about this, but CRRC was put in some funding or a funding request through NOAA's Regional Resilience Competition that was asking for some seed funding for communities to get climate programs started in our region. And that was just a letter of interest. We were actually invited to apply for the full application, which is due in February. And so if that's something that you'd be interested in tapping into and working with us on, we would love to collaborate on that and coordinate. I know we've talked a little bit about it before, so I'll reach out to you separately. But that is, something that CRRC has been trying to do is build up capacity within our communities and get funding for the communities that we serve to be able to get these programs started and up and running.
Right.
Congratulations on that.
Sorry.
Congratulations on that.
Thanks. Well, we still need to get the funding. Like I said, it's just we moved on to
I know.
stage 2, but
Yep, still one step ahead.
Yep.
And I also wanted to mention, I know I'm showcasing a storyboard, but Two Bears Environmental Consulting can also help write grants to help individual villages secure the seed funds that Erin was talking about at like an individual village level. We have a lot of grant writing assistance to get into those programs. And then we also have the capability of actually writing and drafting climate resiliency plans, where we work directly with the villages, and data that we've actually received from the University of Fairbanks as well. So together we can also work on those here at Two Bears.
Awesome, thank you.
And Kristen just put a couple of Melinda and Kristen Haringa with the Alaska Tribal Resilience Learning Network. She put their contact info in the chat.
There was also a question and answer exchange in the chat box between Jeremy and Rick. If you can take notice of that, about the seasonality of the reduced precipitation. There's a little more information there for folks to see. And I would mention for you, Caroline, the Model Forest Policy Program recently worked with the Copper River Native Association in the Upper Copper River watershed and helped facilitate them with doing a regional plan, which is now complete and available. So if you get in touch with us, we can help you get a copy of that. For the Upper Copper River watershed, that was done. It was led by Copper River Native Association, but several of the local villages participated in the process.
Thank you so much. I put my email in the chat, as I think it might be easier for you folks to reach out to me. Although I do see Melinda's email there and Krista, but yep, if I will be reaching out to everyone. Thank you so much.
Yeah, thank you. Any other questions for our panelists? I actually did have one more, or one question, and I'm kind of, you know, Jeremy, you talked a lot about, I think this is kind of directed towards everybody, but based off of what Jeremy was sharing and showing, you know, you talked about all of this uncertainty that we need to include in these models. So I was hoping and wondering if you could give us, you know, why use models at all, and what are some good examples of how models have helped inform, you know, climate action or climate policy in other parts of the state?
Yeah, that's a great question. There's a lot tied up in there. I'd probably talk all day about some of that, but I'll try to keep it to just a couple minutes. I mean, in the absence of future models, you're kind of left with where you're at now and what the trends have been, right? And that would not be a bad place to start. As you saw from Rick's presentation and mine, there's a lot of similarity between the 50-year trends and the same kinds of things we expect over the next 50 years, right? It's a similar progression into the future that the models tell us about. So having looked at that, we can say, well, you could start with the trends we've already experienced. And if we assume those will continue, that's at least a base place to start, right? We know the future is likely to be different than the past we're familiar with, and we don't expect those trends to stop for any reason. We do expect, another piece of the uncertainty is we do expect variability, right? Alaska is a place where the Arctic and the North Pacific meet. And what's going on in those two very different regions has big consequences for our weather on any given time scale, and then our climate averaged over long periods of time. We know that for years or even decades at a time, we can be drier than our historical experience, or wetter or cooler or warmer, right? That variability isn't going to go away. And in some cases, it's, you know, it may change, but it will always still be there. So we have to plan for that also. If we're not ready for the variability that we've already experienced, we know we're not ready for the future. We could also anticipate reasonably that given the trends we already see, that variability could increase, particularly towards conditions we're not used to experiencing, such as the drought that Southeast experienced in 2017 to 2019, or these atmospheric rivers that maybe we had once very rarely historically, and now seem to be more common. Or even, the kinds of storms that affect Western Alaska. Those things seem to be trending different ways, but because they're so rare, they're hard to develop the trends for. Then, when we talk about which future do we, if we have lots of models under lots of scenarios, which future do we think is most likely? That's a tough one to answer because until recently, we thought of all those different climate models, maybe there's, several dozen around the world, as equally plausible, right? They had all good science in them. It's now thought, based on emerging science, that there's a range of them that are more likely than the others. And what the differences among them have to do with how sensitive they are to greenhouse gas concentrations in the atmosphere. Some warm faster, some warm less fast, some warm a little more, some a little less. And they're now thinking that kind of the middle of that range seems to be the most scientifically plausible. The really extreme ones that warm the fastest, we can't rule them out, but they now seem less likely based on other information scientists have. And then the ones that don't seem to respond very much don't seem like the world that we're actually living in, right? That we know that there's a pretty strong response, and we especially see it in places like the Arctic where we live. So all of the tools that Snap builds build in those choices. And one of the things that the tools, there's a lot of text that you can look at, explainer text, that helps guide you into how you should think about the availability of those. Like, which of these toggles do I use? But if you're ever stumped and say, well, I can't pick just one, I want to pick this range of things for a specific purpose, then we should talk about it. I'm happy to help with that. The main thing I would say is, if your planning wants to be risk averse, like you want to be ready for the worst of what could happen, we don't present the worst of what could happen. That's unknown for certain, but we present some of those high-end scenarios that are already alarming enough. And if you're ready for those, then you're probably resilient to lots of other changes as well. If you want to be cavalier about it and plan for the low end and hope that's where we get, or resources don't allow it, then you do what you can, right? It's thought now that kind of that middle high end of the range, IPCC is suggesting that's probably where we're going to end up. Not the highest emission scenarios, not the warmest models, but a little less than that. We're not optimistic about global commitments to reduce greenhouse gas emissions sufficiently that we're going to end up on the low end. We don't think we're going to end up there, at least not the next 50, 60 years. Maybe by 2100 or a little further, we could develop that and get towards that, but we're not there yet.
Thank you. Yeah, it is tough. What is going to happen? Telling the future is impossible, but showing the trends definitely very useful. Thank you. I did notice one more exchange in the chat. Gwen asked for Rick, do we need more long-term monitoring locations in Chugach, and how could we go about doing that? Rick, do you want to, Rick said, yes, we very much need agencies to maintain observation networks. Anything you want to add to that, Rick?
Yes, we absolutely need that. You know, no amount of future funding will allow us to go back in time to get observations we don't have. So it's absolutely critical that we maintain what we have. I would argue that it's more important to maintain what we have from the climate purpose than think about adding new things. If we get to choose one, I say maintain what we have. And unfortunately, and I can't stress this enough, this is where agencies are failing Alaska, because we are going backwards in the maintenance of long-term climate observations and really environmental observations. It's not as extreme in the Chugach region as it is, say, in Western Alaska, but we're not going forward anywhere.
And we already didn't have enough to begin with. Losing
and
more.
We already didn't have enough to begin with, and we're going backward. And that is, and again, we can't really make that up, especially at the local level. You know, it's one thing to the global scale, but none of us live at the global scale. We live at our local and regional level, and that's where those actual observations are most critical.
Yeah, and sometimes I think the most difficult to get, I know, and Jacqueline could probably speak about this a little bit better than I can, because she's been doing it for much longer than I have. But you know, CRRC has been trying to collect at least ocean chemistry data from around our region, and it can just be very challenging sometimes to get consistent sampling opportunities out there in the same locations for a long period of time. Yeah, did you want to add anything to that, Jacqueline?
Yeah, it is. It's quite challenging, and we've been able to maintain long-term data sets from some of our sites. But it's challenging to continue these data sets, and we work very closely with IGAP for some of our sites for funding. I run the Ocean Acidification Research Lab here at APMI at Alutiiq Pride, and we have a lot of data sets that we're trying to push out the door so that they're in manageable, digestible form. And so hopefully we can help with some micro details of these climate models.
So thank you. Yeah, it's and I also know that there was another with that NOAA Regional Resilience Challenge, Native Village of EAC, and I believe Prince William Sound Science Center were also looking at an implementation grant. I don't know if they got asked to the second stage of that, but a couple of that would have added some ocean buoys as well as some weather monitoring stations at schools if they end up getting that program. Okay, well, I don't want to cut into Jamelin's time too much. And so, Jamelin, let's see, I will go ahead and pass it over to you. I did just really quickly want to give about a minute of background on what this is and why we're doing it. So I will share my screen really quickly. And so To provide a little bit of background, this is part of the same grant. This project is part of the same grant that helped fund our climate cohort that is building towards the adaptation plan that CRRC has been working on. As part of that, we wanted to find a way to share data and information in a way that helped contextualize it for people living in the region. So we came up with this idea of a climate change story map that spans the idea of 7 generations. So our current generation kind of being the now, 3 generations in the past looking at historical data and what's happened, and 3 generations in the future looking at kind of future projections of what could happen, with the idea that this helps almost humanize climate change, in that, you know, you can think about, oh, this is what's happening to me now, this is what happened to my grandparents, this is what could happen to, you know, my grandchildren or my great-grandchildren. So the goals of this story map are kind of multiple. It's trying to be a lot of things. We would like to introduce the general public to climate change data and how climate change is impacting the Chugach region. We want to share data and projections for the Chugach region at a scale that can help with future planning efforts. We want to provide context for how climate change can impact ecosystems, economies, and communities in our region. And we also just want to link to additional climate change data and planning resources that are applicable in our region. So Jamelin with Two Bears Consulting has been working really hard on developing a skeleton and a draft of this story map. And so this is really an opportunity. I asked her to share this with everyone just to get some feedback, some input, and some ideas about, are we on the right track? Is there more information that you'd like to see, or would you like to see this presented in a different way? There are some opportunities for, oops, how do I stop sharing? For feedback as well. I just wanted to ask everybody to feel free to raise your hand or speak up with any feedback. Also, you're welcome to email me. I will put my email here in the chat. You can reach me there, or there's also an anonymous Google form that you are welcome to fill out, and we will get the feedback from that. We're also looking for people who would be interested or willing to share stories or observations, images, videos to help put climate change in our region into context. And so if that's something that you are willing to do, please, again, there's a place on that form that you can let us know, and we'll reach out to you, or feel free to email or call us. And Gwen, do you mind sticking? Do you have that link available? Thank you. There is the Google form. And with that, I will pass it over to Jamelin.
All right. Thank you. And I'm very excited to share this dashboard, particularly coming off of those amazing presentations we had today, because it's the culmination of the presentations that we had today that we're really trying to showcase. So the historical data that was presented by Rick, the projections presented by Jeremy, and then of course, the observations and the changes that have been seen on the ground, which was presented by Michael. So it's actually like the fusion of those 3 presentations. So I'm very excited. One of the main goals of this, as Erin had said, is just to make it interactive and visual. So starting this storyboard, we're going to just talk a little bit about the CRRC, some of the goals and the missions, just very briefly, a little bit of what climate change is, similar to how Rick had started his presentation, and talk a little bit about how it can affect the day-to-day life. And then moving slowly off of that introduction, we're going to get into some maps of the data that we have, thinking about this 7-generation change. And we're looking at a couple of different variables for the area. One of them will be just how temperature has changed in those 7 generations, looking at historical data, what it has looked at, what it looks like now, and using projections to see what it may look like in the future. And I'd like to draw some attention to these graphs that we currently have embedded up front. I'm going to show a few different ways to potentially showcase these graphs, and I would love to get some feedback on what works best for everybody. But essentially, as we're talking about temperature, we have these graphs of the different thresholds that might be particularly more meaningful. These type of thresholds and graphs were also showcased in Jeremy Littell's presentation on items of temperature that might be more effective to individuals on the ground. And the first way we thought of showcasing them is we show the temperature map and we have all the extreme indices for temperature on the side. And I'm kind of going to scroll past it quickly. And then the next thing we want to do, keeping in mind the 7 generations, is I'm currently developing maps that'll go in this large area. Right now, it's just a base map. It doesn't have any data, but it will have maps similar to this first map here, which will just show what the temperature was for those different generations. That is, what did the temperature look like in the 50s? What did the temperature look like from the 80s to 90s? Kind of what does this temperature look like now? And then going forward to the 50s and 60s, and then eventually to the 90s and the 100s at the regional scale. And then the idea is that we are going to repeat the same format. We talk a little bit about what temperature, what the trends are, how it's calculated, talk about some of those uncertainties that were brought up in the future projections, and include different links to news articles and videos about how temperature has already affected the area. And then we're going to go into precipitation, touching on showcasing a lot of the data that was presented by Rick, and it's going to follow a very similar format. It'll have different maps that showcase the different generations, and we're going to do this same thing for temperature, precipitation, wind, and snowfall for the area in a very similar pattern. And once we get done talking about the region as a whole, we wanted to get a little bit more nuanced and talk more about the tribes individually. So currently they're all just in alphabetical order. You can click on them on the map to zoom in. Initially, we have a very high level of what tribes there are, what we're going to be looking at. But then, as you can see up here, you can actually click to each of the individual tribes. And from here, this is where we're really hoping to solicit any sort of feedback or stories, videos. That story that Michael brought up about you used to be able to go ice skating, you used to be able to go sledding, quotes like that we could put in that are village specific, but is kind of what we're hoping to have here. And you'd be able to click through information about the villages to talk about these past observations, any large weather events that have happened, or just events in the village overall that have had an effect on the community. And it's in this area that we're hoping to get down and a little bit more personalized. It's also here where was the second option for showcasing these graphs of these indices that are tailored specifically to each region. Another option was to put them at the individual village level instead of at the regional level. Although whether or not those individual village graphs are relevant is some feedback I'm hoping to get, or if it just makes more sense to have these at the regional level, we can present this either way. And then this same format about stories and changes specific to the village would be repeated for each village within the CRRC. And the more feedback and comments and stories and questions that we get, the more detailed each of these individual village tabs can be. And essentially, that's how we're hoping to kind of showcase the complex data and the maps that were talked about by Rick, some of those the indices, the hot day indices, the projections, how it's going to change, which is touched on by Jeremy, and then also incorporating the stories and the actual impacts of these changes at the individual village level. So I think if there's any questions or any sections of this that you want me to go back to or to touch more on, I'd be happy to take any additional comments or questions here in the last couple of minutes, or if it's more comfortable for you to do everything via email in the form, that works as well.
Jamlin, I think unfortunately a number of our community folks had to hop off, which was my biggest worry about making this an hour and a half. But I wasn't quite sure how we'd fit everything into an hour either. So there was kind of that balance. But could you maybe for the folks that are still on the line, would you be willing to kind of talk a little bit about what what extreme indices and what data we've got in it so far, and maybe the conversation here could kind of focus about around, is that data being presented in a way that makes sense, and is there any data especially since I've got Jacqueline on the line right now, just to put you on the spot, Jackie or Jacqueline, is there any other data sets, around, say, ocean chemistry, et cetera, that we might be missing that would be useful and we'd be able to display in here in a way that makes sense?
Sure. So really quick, the temperature, we have temperature, precipitation, snowfall, and wind. And I'm currently in the process of creating the maps. The one map I do have created is the one you're seeing right now. This is for temperature for the year. This is annual temperature for the year 2000. This was actually created using the CMIP6 data that was gridded and rescaled for Alaska. Any of the historical data is based off of both observational data sets and the ERA 5 model kind of combined together. And then any future data sets were based off of the CMIP6, which is the most recent data presented from the IPCC. It was regridded and downscaled to Alaska. And so it's those temperature data that's going to be presented. All of the maps will be at the regional scale, because as you zoom in to the villages at that finest scale, you're not going to see necessarily an overall amount of change. And then a lot of the specific indices that we look at for temperature are the cold day threshold. So how many days in the year are colder than a threshold set, which I actually can't remember the threshold right off the bat. And in hindsight, I should have had that pulled up. But and that also works with cold day duration. How long is it actually going to be cold? How long is it going to be hot? And I can find the individual threshold numbers to send out. And that's something that I will have written into this website as well for people to read. It's a little bit more of what these graphs actually mean. We also have warm spell duration indices for temperature. And then for precipitation, we have ones like the 1-day precipitation maximums, 5-day precipitation, consecutive dry days or consecutive wet days, consecutive days of heavy precipitation. And we also will have similar graphs for snowfall and wind, which will be the amount of snowfall per season or per month. And as far as wind, it's days of high wind, number of extreme wind events throughout the year. And these are all going to 2100.
Awesome, thank you. I noticed Rick has a question or a comment. Go ahead, Rick.
Oh, just a comment. Sometimes something we run into is I would just encourage you to make sure that the values you pick for warm or cold or high winds or whatever, that they're regionally relevant. Sometimes some of the international standards that get used don't really seem appropriate for Alaska. And so to maximize their use for the region, things really need to be regionally relevant. Like here in the interior, like internationally, a cold day, defined as a temperature below freezing. Well, that's not helpful in the interior, right? So just that would just be a suggestion I would make is make sure you pick those thresholds so that they're meaningful for the region.
Right, and that's definitely something that I'll look into and make sure is accurate. Thank you for pointing that out and drawing attention. We'll reach out to double check those threshold numbers.
And that's actually kind of funny that you say that, because I know when you and I, Jeanlyn, were talking about this originally and kind of what indices we'd use, actually just some of them I cut out because I was like, I don't actually think this cold temperature index is that useful for our region, because most of the time it's below that. I think it was like 25 degrees Fahrenheit or something. It wasn't super cold, but it also just wasn't super relevant. So
right, and we certainly have the ability to edit the threshold, so I can check what number it is right now, and if it's not regionally relevant, that is something that we can edit on the fly to make sure that the data presented here is appropriate for the region.
Awesome. And yeah, great point, Rick. Thank you.
Yeah, thanks.
Any other questions or comments? Well, Jamelin, I think that this is looking really good so far. I'm very excited for it. I know that we need to get you some comments and some feedback and some content as well. But I think that I really appreciate you sharing this with us here. And I think that maybe a next step kind of for us and getting feedback and input on this is maybe trying to take it before CRRC's board. And also advertising over Facebook and doing some outreach and going through our archives to help fill this out and populate it.
Yeah, and once the maps are completed as well, it'll be significantly more impactful. So I'm excited to share that.
Yes, thank you for taking the plunge and showcasing, showcasing something that I know you might not have been quite ready to showcase, but it is coming along very well, and I think it'll be really useful.
Thank you.
Great. Well, Margaret, did you have any comments? And as she just came on.
No, it was just really interesting to see, because there had been a kind of a preliminary showcase of it, and so it's nice to see where it's developed to. So it seems like a few months ago there was an earlier one, so it's great to see.
Thanks. Yeah, we did share kind of the very, very, very first draft with the climate cohort.
Right. And it's great to see the new website, that the Northern Arctic website, which we're going to be using for the Norton Bay area. I'm going to be digging into that further for the Norton Bay area and looking at some of those climate projections related to Elam and that area. So it was great to see that one.
Well, thank you for being a part of this. And yeah. Great. Well, thank you all very much for your time. Thank you, presenters, for presenting. Thank you for those of you who helped run things behind the scenes and make this go smoothly. And thank you for those who tuned in to learn more and find out what's happening in the region. I really appreciate your time. Really appreciate your passion and your dedication to making the Chugach region a climate-ready region in Alaska.
Thank you all. Have a good month.
Thanks, everyone.
Bye. Thank you.